Good morning, fellow BBDers, and welcome to today's discussion on GraphQL, the game changer in modern application development. So today we're diving deep into the exciting world of GraphQL. I'm going to try my best to convince you that it's very cool, and we're going to uncover its transformative potential in revolutionizing how we build and interact with APIs. So what is GraphQL? Picture this, you're knee-deep in building an application, and you're faced with the classic challenge of fetching data from a server. In the realm of traditional RESTful APIs, this often means grappling with fixed data structures scattered across multiple endpoints. The result, a tangled mess of overfetching and underfetching, wasting precious time and resources. So GraphQL, developed by Facebook in 2015, is a query language and server-side runtime for APIs, designed to prioritize one thing above all else, giving clients exactly what they ask for. One of GraphQL's most powerful features is its ability to consolidate multiple APIs and database connections behind a single unified endpoint. This means no more juggling endpoints or wrestling with different data sources. With GraphQL, you have the tools you need to create a consistent, predictable API that can be seamlessly integrated across all of your clients. GraphQL's declarative model simplifies the process of extending your API, making it effortless to add new features and extend functionalities. Clients benefit from a clear and structured interface for querying data. Beyond data fetching, GraphQL empowers developers to shape and modify data, whether they're creating new APIs from scratch or wrapping existing ones. So now that you know a little bit about GraphQL, let's break down the differences between GraphQL and REST. GraphQL and REST are two distinct approaches for designing APIs for exchanging data over the internet. Put simply, RESTful architecture operates on the basis of multiple endpoints and fixed data structures, whereas GraphQL is an API query language that defines specifications of how clients' applications should request data from a remote server and employs a single flexible endpoint for queries. With REST, obtaining data from various endpoints means multiple requests, potentially slowing down the application and increasing latency. Conversely, GraphQL enables the retrieval of comprehensive data through a single query, thereby minimizing round trips between client and server, enhancing performance. Now let's dive into an example. Imagine a situation where a client wants to fetch data for an order, the products associated with the order, and each product's details. With REST, if a client wants to display this list of orders along with their product and product details, it may need to make multiple requests to different endpoints. Another solution would be to send a fixed data structure from all foreign key linked tables, though this is expensive. This leads to overfetching because the client may receive more product details than necessary, and underfetching because the client may have to make additional requests to get the product details for each product to display. In this GraphQL query, the client specifies the exact fields it needs for the orders, its products and product details, eliminating the need for multiple round trips to the server. GraphQL excels in scenarios like this, where the client needs to fetch complex nested data structures with precise control over the return fields. So now, why is GraphQL so cool? It's all about declarative data fetching. With GraphQL, clients can express their data requirements in a declarative manner, specifying the exact fields and nested structures they need in a single query. This declarative approach eliminates the guesswork and ambiguity often associated with data fetching from traditional APIs. Moreover, the hierarchical structure of GraphQL allows these entities to be organized in a graph-like fashion, where relationships between entities are represented as edges connecting nodes. This enables the client to navigate these relationships seamlessly when querying data, resulting in more intuitive and concise queries. Additionally, GraphQL schemas define the types of data available in the API, providing strong typing and better error checking. This ensures that clients receive data that adheres to a well-defined structure, reducing the likelihood of runtime errors and improving overall reliability. GraphQL supports advanced features like batching and caching. Batching enables multiple queries to be consolidated into a single request. Additionally, caching mechanisms can be implemented to store frequently accessed data, further improving performance by minimizing redundant data retrieval. Furthermore, GraphQL's optimized query execution enables the server to efficiently process complex queries, retrieving multiple related pieces of data in a single request. This streamlines the data retrieval process and contributes to overall performance enhancements. The GraphQL ecosystem includes a wide range of tools and libraries for building and consuming GraphQL APIs. Apollo is among them. Apollo Client is a popular choice for client-side development due to its excellent developer experience. Apollo Server is is a GraphQL server that is compatible with any GraphQL client, allowing you to build a production-ready GraphQL API that can use data from any source. Relay, developed by Facebook, is another option for a GraphQL client, designed for large-scale applications with complex data requirements. Relay provides a set of powerful tools for managing data fetching, caching, and synchronization in React applications. Its declarative approach to data fetching and strong integration with React components make it an asset for building sophisticated GraphQL-powered applications. In addition to Apollo and Relay, the GraphQL ecosystem boasts a variety of other tools and libraries catering to different aspects of the GraphQL development process, from server-side frameworks like GraphQL Yoga to testing utilities like GraphQL Tools and Apollo Client Mocking. Developers have access to a wealth of resources to enhance their GraphQL products. With such a rich and diverse ecosystem, developers can choose the tools and libraries that best suit their needs and preferences, empowering them to build scalable, performant GraphQL APIs. At the core of GraphQL lies its schema. The schema acts as a guiding framework for the GraphQL APIs, outlining the types of data that can be queried, mutated, or subscribed to. Object types within the schema specify the nature of the object that clients can request and the fields associated with each object. As queries are received, the GraphQL validates them against the schema to ensure compliance with the defined structure before executing them. Resolvers play a pivotal role in the GraphQL execution process by fetching the requested data for each field in the schema and delivering it to the client. Each field in the schema is linked to a resolver function, which is responsible for retrieving the corresponding data during execution. From the client's perspective, the primary goal of GraphQL operations typically revolve around queries and mutations. Queries enable the clients to fetch data from the server, similar to the read operation in the CRUD model. On the other hand, mutations facilitate data modification operations such as creation, updating, and deletion. GraphQL clients handle the transmission of queries and mutations to the server and process the responses accordingly, empowering smooth communication between clients and servers. So now let's take a glimpse at real-world success stories. A few notable organizations that have reaped the benefits of adopting GraphQL in their production environments are PayPal, Netflix, the New York Times, NerdWallet, and more. Now we'll dive deeper into one of these case studies to understand how GraphQL revolutionized the operations of a global streaming giant like Netflix. Netflix, as a leading streaming platform, encountered significant challenges with traditional REST APIs due to the complexity of its data requirements and the diverse needs of its user base. With millions of subscribers worldwide, Netflix needed a solution that could efficiently deliver client-specific data without overloading the network with unnecessary payloads. GraphQL emerged as the ideal choice for Netflix to address these challenges, offering a flexible and efficient approach to data fetching, tailored to the platform's unique demands. In transitioning from REST to GraphQL, Netflix undertook a strategic migration process to integrate GraphQL into its existing architecture seamlessly. Netflix invested in training and upskilling its development teams to ensure a smooth transition to GraphQL. By leveraging GraphQL's schema-driven approach, Netflix redesigned its data fetching mechanisms to align more closely with the specific requirements of each client, resulting in a more streamlined and optimized user experience. By minimizing data transfer and optimizing query execution, Netflix achieved notable reductions in network bandwidth usage, resulting in faster load times and smoother content delivery. With GraphQL, Netflix experienced accelerated time to market for new features and enhancements, allowing the platform to innovate more rapidly and respond to evolving user preferences with agility, reinforcing the platform's position as a forerunner in the industry. So now let's do a little demo to bring GraphQL to life. This is Apollo Explorer, a GraphQL IDE in the cloud, specifically tailored to GraphQL developers. One of the first things that we will be taking a look at is the schema view. If it loads, here we go. Here you can visualize the structure of your GraphQL schema, including the types, queries, mutations, and subscriptions it defines. With the schema view, you'll notice a special query type. This is the root query. This serves as an entry point for every GraphQL query. It defines the available fields and their types the clients can request. Now, over here, we have the schema definition language page. This is where you can view your schema in its raw form. And over here, we have a graphical representation of your schema and its nodes represented with edges. With these tools in hand, let's proceed to make a query. We'll start at the root query and generally build it up, adding the fields that we're interested in. So here's our root query. Say we want to select all the planets with their names and their ID numbers, but we also want species, their eye color, their hair color, whatever you want, whatever you need. And you can make your query. So in conclusion, thank you for listening. I hope I've convinced you that GraphQL is pretty cool, and I trust that soon we will see it being more widely used.